Hi, greetings to all of you. Today we are going to see about top 100 data science interview questions for cracking any interviews. This will be very helpful for you to refresh your knowledge in data science, and it will also boost your data science knowledge. If you find the question and the answers to be difficult in understanding, or else if it is wrong, you can please feel free to comment in the comment sections below. Okay, let's move into the questions and the answers. So, the first one is, what is the difference between supervised and unsupervised machine learning? Supervised machine learning requires training labeled data. So, it should always have some target column with some labeled data, and an unsupervised machine learning doesn't require labeled data. What is bias variance trade-off? Bias is an error introduced in a model due to oversimplification of machine learning algorithm. It can lead to underfitting. When you train your model at the time, model makes simplified assumptions to make the target function easier to understand. Low bias machine learning algorithms like decision trees, KNN, and SVM, and high bias machine learning algorithms like linear regression, logistic regression, etc. So, what is meant by variance? Variance is error introduced in your model due to complex machine learning algorithm. Your model learns noise also from the training dataset and performs bad on test dataset. It can lead high sensitivity and overfitting. Normally, as you increase the complexity of your model, you will see a reduction in error due to lower bias in the model. However, this only happens till a particular point. As you continue to make your model more complex, you end up overfitting your model, and hence your model will start suffering from high variance. So, the bias variant traders, the goal of any supervised machine learning algorithm is to have low bias and low variance to achieve good prediction performance. For example, the k nearest neighbors algorithm has low bias and high variance, but the trade-off can be changed by increasing the value of k, which increases the number of neighbors and contribute to the prediction, and in turn increases the bias of the model. The support vector machine learning algorithm has low bias and high variance, but the trade-off can be changed by increasing the C parameter that influences the number of violations of the margin allowed in the training data, which increases the bias but decreases the variance. There is no escaping the relation between bias and variance in machine learning. Increasing the bias will decrease the variance, and increasing the variance will decrease the bias. What is exploding gradients? Exploding gradients are a problem where large error gradients accumulate and result in very large updates to neural network models weights during training. At an extreme, the values of weights can become so large so to overflow and results in NAN values. This has the effect of your model being unstable and unable to learn from your training data. Now let's understand what is the gradient. Gradient is the direction and magnitude calculated during training of a neural network that is used to update the network weights in the right direction and by the right amount. What is a confusion matrix? The confusion matrix is a 2 into 2 cross table that contains 4 outputs provided by the binary classifier. Various measures such as error rate, accuracy, specificity, sensitivity, precision, and recall are derived from it. The dataset used for performance evaluation is called test dataset. It should contain the correct labels and predicted labels. The predictor labels will exactly the same if the performance of a binary classifier is perfect. The predictor labels usually match with part of the observed labels in real world scenarios. A binary classifier predicts all data instances of a test dataset as either positive or negative. This produces 4 outcomes. One is true positive, correct positive prediction, false positive, incorrect positive prediction, true negative, correct negative prediction, false negative, incorrect negative prediction. The basic measures derived from the confusion matrix will be error rate equal to summation of false positive plus false negative divided by positives plus negatives. Accuracy is equal to true positive plus true negative divided by positives plus negative. Explain how a ROC curve works. The ROC curve is a graphical representation of the contrast between true positive rates and false positive rates at various methods. It is often used as a proxy for the trade-off between the sensitivity and the false positive rate. What is selection bias? Selection bias occurs when sample obtained is not representative of the population intended to be analyzed. Explain SVM machine learning algorithm in detail. SVM stands for support vector machine. It is a supervised machine learning algorithm which can be used for both regression and classification. If you have n features in your training dataset, SVM tries to plot it in n dimensional space with the value of each feature being the value of particular coordinate. SVM uses hyperplanes to separate out different classes based on the provided kernel function. What are the support vectors in SVM? We see that the thinner lines mark the distance from the classifier to the closest data points called the support vectors. Darkened data points, the distance between the two thin lines is called the margin. What are the different kernel functions in SVM? Linear kernel, polynomial kernel, radial basis kernel, and sigmoid kernel. Explain decision tree algorithm in detail. Decision tree is a supervised machine learning algorithm mainly used for regression and classification. It breaks down a dataset into smaller and smaller subsets, while at the same time an associated decision tree is incrementally developed. The final result is a tree with decision nodes and leaf nodes. The decision tree can handle both categorical and numerical data. What is entropy and information gain in decision tree algorithm? The core algorithm for building decision tree is called ID3. ID3 uses entropy and information gain to construct a decision tree. Entropy. The decision tree is built top down from a root node and involve partitioning of data into homogeneous subsets. The ID3 uses entropy to check the homogeneity of a sample. If the sample is completely homogeneous, then the entropy is 0, and if the sample is unequally divided, it has an entropy of 1. So entropy's formula is minus probability log to the power of probability of a single class minus probability log to the power of probability of the another class. Information gain. The information gain is based on the degrees in entropy after a dataset is split on an attribute. Constructing a decision tree is all about finding attributes that returns the highest information gain. So gain of t comma x is equal to entropy of t minus entropy of t comma x. What is pruning in decision tree? When we remove subnodes of a decision tree, this process is called pruning or opposite process of splitting. What is ensemble learning? Ensemble is the art of combining diverse set of learners' individual models together to improvise on the stability and predictive power of the model. Ensemble learning has many types, but two more popular ensemble learning techniques are mentioned below. Bagging, the first one. Bagging tries to implement simpler learners on small populations and then takes the mean of all the predictions. Similar learners on one population and then takes a mean of all the predictions. In generalized bagging, you can use different learners on different population, as you expect this help us to reduce the variance error. In boosting is an iterative technique which adjusts the weight of an observation based on the last classification. If an observation was classified incorrectly, it tries to increase the weight of this observation and vice versa. Boosting in general decreases the bias error and builds strong predictive models. However, they may overfit on the training data. What is random forest? How it works? Random forest is a versatile machine learning method capable of performing both regression and classification tasks. It is also used for dimensionality reduction, treats missing values, outlier values. It is a type of ensemble learning method where a group of weak models combine to form a powerful model. In random forest, we grow multiple trees as opposed to a single tree to classify a new object based on attributes. Each tree gives a classification. The forest chooses the classification having the most votes over all the trees in the forest, and in case of regression, it takes the average of outputs by different trees. What cross-validation technique would you use on a time series dataset? Instead of using k-fold cross-validation, you should be aware to the fact that a time series is not randomly distributed data. It is inherently ordered by chronological order. In case of time series data, you should use techniques like forward chaining where you will be model on past data, then look at forward facing data. So it will be like fold 1 equal to training 1 comma test 2, and fold 2 equal to training 1 comma 2 then test 3, then fold 1 equal to training 1 comma 2 comma 3 comma test 4. So what is logistic regression? Or state an example when you have used logistic regression recently. Logistic regression, often referred to as logit model, is a technique used to predict the binary outcome from a linear combination of predictor variables. For example, if you want to predict whether a particular political leader will win the election or not, in this case the outcome of prediction is binary, that is 0 or 1, win or lose. The predictor variables here would be the amount of money spent for election campaigning of a particular candidate, the amount of time spent in campaigning, etc. So what do you understand by the term normal distribution? Data is usually distributed in different ways with a bias to the left or to the right, or it can all be jumbled up. However, there are chances that the data is distributed around a central value without any bias to the left or right and reaches normal distribution in the form of a bell-shaped curve. The random variables are distributed in the form of a symmetrical bell-shaped curve. What is Box-Cox transformation? The dependent variable for a regression analysis might not satisfy one or more assumptions of an ordinary least squares regression. These residuals could either curve as the prediction increase or follow skewed distribution. In such scenarios, it is necessary to transform the response variable so that the data meets the required assumption. A Box-Cox transformation is a statistical technique to transform non-normal dependent variables into a normal shape. If the given data is not normal, then the most of the statistical techniques assume normality. Applying a Box-Cox transformation means that you can run a broader number of tests. A Box-Cox transformation is a way to transform non-normal dependent variable into a normal shape. Normality is an important assumption for many statistical techniques. If your data isn't normal, applying a Box-Cox means that you are able to run a broader number of tests. The Box-Cox transformation is named after statisticians George Box and Sir David Roxby Cox, who collaborated on a 1964 paper and developed the technique. How will you define the number of clusters in a clustering algorithm? Though the clustering algorithm is not specified, this question will mostly be asked in reference k-means clustering, where k where K defines the number of clusters. For example, the following image shows three different groups. Within the sum of squares is generally used to explain the homogeneity within the cluster. If you plot WSS for a range of number of clusters, you will get the plot shown like in the shape of an elbow. The graph is generally known as elbow curve. So at the end of the elbow, the variance will start decreasing and the error will also start decreasing. So the number of clusters, that is the number of clusters equal to 6, is the point after which you don't see any decrement in WSS. That is within group sum of squares. This point is known as bending point and taken as K in K means. This is the widely used approach, but few data scientists also use hierarchical clustering first to create dendrograms and identify the distinct groups from there. What is deep learning? Deep learning is a subfield of machine learning inspired by structured and function of brain called artificial neural network. We have a lot of numbers of algorithms under machine learning like linear regression, SVM, neural network, etc. And deep learning is just an extension of neural networks. In neural nets, we consider a small number of hidden layers, but when it comes to deep learning algorithms, we consider a huge number of hidden layers to better understand the input-output relationship. What are recurrent neural networks? So recurrent nets are types of artificial neural networks designed to recognize patterns from the sequence of data such as time series, stock market and government agencies, etc. To understand recurrent nets, first you have to understand the basics of feed-forward nets. Both these networks, RNN and feed-forward, named after the way they channel information through a series of mathematical operations performed at the nodes of the network. One feeds information through straight, nerve touching and same node twice, while the other cycles in through loop, and the latter are called recurrent. Recurrent networks, on the other hand, take as their input not just the current input, example they see, but also what they have perceived previously in time. The BTSXPE at the bottom of the drawing represents the input example in the current moment, and the context unit represents the output of the previous moment. The decision a recurrent neural network reached at the time t-1 affects the decision that it will reach one moment later at time t. So recurrent networks have two sources of input, the present and the recent past, which combine to determine how they respond to new data, much such we do in life. The error they generate will return via back propagation and be used to adjust their weights until error can't grow any lower. Remember, the purpose of recurrent nets is to accurately classify sequential input. We rely on the back propagation of error and gradient descent to do so. Back propagation in feed-forward networks moves backward from the final error through the outputs, the weights and inputs of each hidden layer, assigning those weights responsibility for a portion of the error by calculating their partial derivatives, or the relationship between their rates of change. Those derivatives are then used by our learning rule gradient descent to adjust the weights up or down, whichever direction decreases error. Recurrent networks rely on an extension of back propagation called back propagation through time, or BPDT. Time, in this case, is simply expressed by a well-defined ordered series of calculations linking one time step to the next, which is all back propagation needs to work. What is difference between machine learning and deep learning? Machine learning is a field of computer science that gives computers the ability to learn without being explicitly programmed. Machine learning can be categorized in following three categories. One is supervised machine learning, unsupervised machine learning, and reinforcement learning. Deep learning is a subfield of machine learning concerned with the algorithms inspired by the structure and function of brain called artificial neural network. What is reinforcement learning? Reinforcement learning is learning what to do and how to map situations to actions. The end result is to maximize the numerical reward signal. The learner is not told which action to take, but instead must discover which action will yield the maximum reward. Reinforcement learning is inspired by the learning of human brains. It is human beings. It is based on the reward and penalty mechanism. What is selection bias? Selection bias is the bias introduced by the selection of individuals, groups, or data for analysis in such a way that the proper randomization is not achieved, thereby ensuring that the sample obtained is not representative of the population intended to be analyzed. It is sometimes referred to as the selection effect. The phrase selection bias most often refers to the distortion of a statistical analysis resulting from the method of collecting samples. If the selection bias is not taken into account, then some conclusions of the study may not be accurate. Explain what regularization is and why it is useful. Regularization. Regularization is the process of adding tuning parameter to a model to induce smoothness in order to prevent overfitting. This is most often done by adding a constant multiple to an existing weight vector. This constant is often the L1 lasso or L2 ridge. The model prediction should be then minimize the loss function calculated on the regularized training set. What is TF-IDF vectorization? TF-IDF is a short term for term frequency. Inverse document frequency is a numerical statistic that is intended to reflect how important a word is to the document in a collection or corpus. It is often used as a weighting factor in information retrieval and text mining. The TF-IDF value increases proportionally to the number of times a word appears in the document, but it is offset by the frequency of the word in the corpus, which helps to adjust for the fact that some words appear more frequently in general. What are recommender systems? A subclass of information filtering systems that are meant to predict the preferences or ratings that a user would give to the product. Recommender systems are widely used in movies, news, ratings, research articles, products, social tags, music, etc. What is between regression and classification ML techniques? Both regression and classification machine learning techniques come under supervised machine learning algorithms. In supervised machine learning algorithm, we have to train the model using labeled dataset. While training, we have to explicitly provide the correct labels, and algorithm tries to learn the pattern from the input to output. If our labels are discrete values, then it be a classification problem, example A, B, etc. But if our labels are continuous values, then it will be a regression problem, example 1.23, 1.333, etc. If you are having 4 GB RAM in your machine and you want to train your model on 10 GB dataset, how would you go about this problem? Have you ever faced this kind of problem in your machine learning or data science experience so far? First of all, you have to ask which ML model you want to train. For neural networks, the batch size with NumPy array will work. Step the load the whole data in NumPy array. NumPy array has a property to create mapping of complete dataset. It does not load complete dataset in memory. You can pass index to NumPy array to get required data. Use this data to pass to neural network. Have small batch size. For SVM, partial fit will work. Steps: divide one big dataset in small size datasets. Use partial method of SVM. Partial fit method of SVM. It requires subset of complete dataset. Repeat step 2 for other subsets. What is p-value? When you perform a hypothesis test in statistics, a p-value can help you determine the strength of your results. P-value is a number between 0 and 1. Based on the value, it will denote the strength of the results. The claim which is on trial is called null hypothesis. Low p-value lesser than 0.05 indicates strength against the null hypothesis, which means we can reject the null hypothesis. High p-value greater than 0.05 indicates strength for the null hypothesis, which means we can accept the null hypothesis p-value of 0.05. Indicates the hypothesis could go either way. To put it in another way, high p-values, your data are likely with a true null. Low p-values, your data are unlikely with the true null. What is naive and naive bias? Naive bias algorithm is based on the Bayes theorem. Bayes theorem describes the probability of an event based on prior knowledge of conditions that might be related to the event. What is naive? The algorithm is naive because it makes assumptions that may or may not turn out to be correct. So I hope all these questions and answers would be very helpful to you. So you don't need to spend extra time for this. So whenever you are traveling for an interview, or else whenever you are traveling for some places, you can just put on your headsets and hear the questions and the answers for it, which will throw a lot of questions to you, and also which will make you to just wake up with the, oh yeah, we have learned these things so in the past, like that. So it will be very helpful for you in refreshing your knowledge. So thank you. I hope this video would be useful to you. Thank you for watching this video, and take care.